Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring how to simplify rational expressions. So, a rational expression is a ratio of two polynomials, provided that the denominator is not equal to 0. So, in symbols, this would be a rational expression is equivalent to a over b, where a and b are polynomials, and b cannot equal 0. In the definition, notice that b cannot equal 0 for the denominator b. The denominator of a rational expression must not equal to 0. The denominator of a rational expression must not equal 0 because division by 0 is undefined. So an example of a rational expression might be something like 3x plus 2 over x minus 4, where x cannot equal 4. Because if x were to equal 4, look what would happen to the denominator. If I were to plug in a 4 for x, 4 minus 4 is 0. That would cause the denominator to be 0. So that means your expression would become undefined. So in a rational expression, your denominator can never equal 0, because if it does, it's undefined. Now, when we simplify a rational expression, we are producing an equivalent expression for most values of x. So, for example, when we, let me just show you with numbers. If you had the fraction 4 over 8, we could say that is equivalent to 1 over 2. 1/2 would be the simplified version. We can also do that with rational expressions. So if I have this expression here, x squared minus 4 divided by 2x minus 4, it has an equivalent expression, which is x plus 2 over 2. In other words, x squared minus 4 over 2x minus 4 is the original, and x plus 2 over 2 is called the simplified version. Now, later we're going to get into how to find the simplified version, but right now I just want to prove that those two expressions are equivalent. So to do that, we're going to use a table of values, and we're going to say, if I were to plug in x equals 0 into that first function, x squared minus 4 over 2x minus 4, I would get out a 1 here and a 1 here. They're equivalent for x equals 0. What about when I plug in a 1? All right, if I plug in a 1, notice I get a 1.5 for the first expression and a 1.5 for the second expression. So they're equivalent for x equals 1. What about x equals 2? Well, when x equals 2, I get an undefined and a 2. So something's going on right there we need to look into. All right, our next x value, if I plug in a 3, I get 2.5 and 2.5, so they're equivalent. And if I plug in a 4, I get 3 and 3, so they're equivalent there. The only place they're not equivalent is x equals 2. So in part B, we're going to explore why. It says in part B, the two expressions are not equivalent for an input value of x equals 2. Explain why. Well, if I have a function that looks like this, f of x is equal to x squared minus 4 over 2x minus 4. What would happen if I plug in x equals 2 for every value of x? I would get 2 squared minus 4 on the top, and on the bottom I would get 2 times 2 minus 4. All right, so on the top, 2 squared is 4, 4 minus 4 is 0. Perfectly fine. 0 can be in your numerator, no problem. But look what happens on the bottom. 2 times 2 is 4, 4 minus 4 is 0. And division by 0 is undefined. So that's why we're getting an undefined when x equals 2. So for our explanation, it says explain why they're not equivalent when x equals 2. So when x is equal to 2, x squared minus 4 over 2x minus 4 is undefined. defined because the denominator, and I'll just abbreviate that, is equal to 0. All right. Now, in example 2, it says find an equivalent expression for each one of the following by first expressing them as a product of two fractions, one of which is equal to 1. Now, that sounds a little confusing, but let me show you what they mean here. So 18 divided by 12. I'm trying to find an equivalent expression for that. So what I'm going to do is I'm going to rewrite 18 and 12 as a product of factors. So for 18, I'm going to rewrite that as 3 times 6. And for 12, I'm going to rewrite that as 2 times 6. Okay. Now I'm going to split these two numbers apart because it says I want to write them as a product. Let me just highlight that. Of two fractions. A product of two fractions. One of them of which is equal to 1. So we would have here 3 over 2. That's my first fraction. Times 6 over 6. Now, what is 6 divided by 6? Isn't that just 1? So this is literally 3 over 2 times 1. So the simplified version of 18 over 12 is simply 3 over 2. I mean, that's something you probably learned to do in 5th or 6th grade. Now, we can also apply this to rational expressions the same way. If I have 3x over 9x squared and I wanted to simplify that, I could rewrite this as 3x divided by, and I can split up 9x squared into 3x times 3x. Okay. Now I'm going to rewrite this as a product of two fractions. Yes, as two fractions. So I'm going to take this first 3x and put it over the bottom 3x. And then it might help you if you do this, because we don't, on the top we don't have another 3x. So this would be 1 over 3x. Now, just like 6 divided by 6 is equal to 1, 3x divided by 3x is also equal to 1. So if I wanted to simplify 3x over 9x squared, that's simply 1 over 3x. That would be its simplified form. Okay. All right, let's look at C. We have x squared minus 9 divided by 2x plus 6. So I want to factor these. So on the top, I would have x plus 3, x minus 3, because we have a difference of two squares. Now, to factor the denominator, the only thing we can do on the denominator is take out the common factor, which is 2. So if I were to divide both those by 2, 2x divided by 2 would leave me x, and 6 divided by 2 would leave me 3. Now, look for your factors that could form a fraction that's equal to 1. Hopefully, you notice these two factors are the same. So I can rewrite this as a product of two fractions by putting the top x plus 3 over the bottom x plus 3. And then for my second fraction, whatever's left over, which was x minus 3 over 2. Now, just like 6 divided by 6 was 1, and then 3x divided by 3x was equal to 1, x plus 3 divided by x plus 3 is also equal to 1. So x squared minus 9 divided by 2x plus 6 would simplify to x minus 3 over 2. All right, example 3. Simplify each of the following. Simplify each of the following. So for 8m squared n divided by 24 mn cubed, I'm going to rewrite this as 8 times m times m times n divided by 3 times 8 times m times n times n times n. All right, so let's look at our fractions. Let's look at our factors that could equal 1. So hopefully you're noticing the 8 an 8, so 8 over 8 times, then I'm hoping you'll notice the m over m. You know what? I'm going to make this, let me erase this. I'm going to make this a little bigger. So we have 8 over 8. Then I have an m and an m. And then I have an n and an n. And then whatever's left over. So on the first one, I had an m left on the top, and on the bottom, I had a 3 and 2 n's, so n squared. All right. Now, 8mn divided by 8mn is 1 times 3n squared. So 8m squared n over 25mn cubed would reduce to m over 3n squared. Example 3, 6p squared minus 8p divided by 9p squared minus 12p. Now on the top here, if I want to factor out the common factor, I'm going to take out a 2p. So that would leave me 3p minus 4. On the bottom, let's see what we can divide out. We can divide out a 3p. So 3p squared divided by 3p would give me 3p. 12p divided by 3p would give me 4. Now, on this problem, I'm going to skip a step. Because wouldn't this divided by this equal to 1? That would divide to 1. Okay, 3p minus 4 divided by, that would equal 1. And wouldn't p, let me get a different color here. P divided by p also equal to 1? P divided by, so what would be left when we divide out those common factors? All we would have left is 2 over 3. All right, let's look at our next problem. We have 6w squared plus 5w minus 4 is equal to 4w squared minus 1. So let's see. On my first one, I'm going to have to factor this trinomial. So I'm thinking I'm going to use 2w and 3w to multiply together to get 6w squared. Now for 4, I could use 1, 4 or 2, 2. So let me think about this. 1, 4. Yeah, 1, 4 would work here. 1, 4. I would need that to be positive and this to be negative. Let me just check my work mentally. 8, negative 3. Yes. Okay, so that's the top. Now we're going to factor the bottom. So we have 4w squared minus 1, and I want to factor that. When I do, this is a difference of 2 squares. So this would be 2w plus 1, 2w minus 1. Now, look for any factors that would divide out to equal 1. So hopefully you're noticing that this factor and this factor are identical. So 2w minus 1 divided by 2w minus 1, when I divide those, I get 1. So all that's left over is 3w plus 4 divided by 2w plus 1. All right, problem C. 2x squared plus 12x plus 18 divided by 3x squared plus minus 3x minus 36. Now, the first thing I'm noticing here is I have some common factors. So let me take a 2 out of this top. That would leave me x squared plus 6x plus 9. Yeah. Now on the bottom, I have a common factor of 3. So let me divide out a 3. So that would be x squared minus x minus 12. Now, I can factor those further because right now, I don't see anything that would divide out to equal 1. So I need to keep factoring those a little further. If I factor the numerator, x squared plus 6x plus 9, I would get an x and an x for the x squared. For the 9, I could use 1, 9 or 3, 3, but I'm going to need to use 3, 3 in this case. So plus, plus. All right, so that's the top. Now let's break down the bottom. x squared minus x minus 12. For x squared, I'll use x times x. For the 12, I could use 1 12, 2 6, 3 4. But I'm going to use a 3 and a 4 and make the 4 negative. Now, what I want you to do is look for a common factor that would divide to equal 1. Hopefully you noticed that we had this and this. That's the only thing I'm seeing that will divide out or cancel out to equal 1. So whatever's left over, whatever's remaining is your final answer. So 2 parentheses, x plus 3 is all that's left on top. And on the bottom, all that's left is 3 parentheses, x minus 4. Now, a special thing occurs when we're simplifying expressions of the form x minus y, y minus x. So notice that the variables are switched here. Okay, now let's watch what happens. Let's say I had 3 minus 2 divided by 2 minus 3, and I want to simplify it. So 3 minus 2 is 1. Whoops, I did not want that. Let's erase that. I wanted my pen. 3 minus 2 is 1, and 2 minus 3 is negative 1. Now, what is 1 divided by negative 1? Well, our answer is negative 1. So see here we had x minus y, and then over here we had y minus x. All right, and when we simplified that, we got negative 1. Now, let's look at that again. We have 12 minus 9. Here's our x minus y. And then we have y, 9, minus x. So we have x minus 1 on the top, y minus x on the bottom. Let's see what happens. 12 minus 9 is 3. 9 minus 12, negative 3. Now, when I simplify that, again, I get negative 1. So if I have a minus b over b minus a, do you see how it fits that pattern? I don't even need to factor anything. I can tell you that's going to equal negative 1. So if I have a minus b over a minus b, that equals 1. Okay, but if I have a minus b over b minus a, that's going to equal negative 1. Okay, very important that you recognize that. Now, let's simplify some expressions where we have to work with this fact. So look at D. We have 2x minus 10 divided by 25 minus x squared. So what we want to do is factor the top, then factor the bottom. So if I factor the top, the only thing I can really do on the top is to divide out a 2. So 2x divided by 2 leaves me x. 10 divided by 2 leaves me 5. All right, now if I factor the bottom, we have 25 minus x squared. So that's a difference of 2 perfect squares. So this would be 5 plus x times 5 minus x. Now, what I want you to notice is this factor here and this factor here. So x minus 5, 5 minus x, that divides out to be negative 1. Negative 1, not 1, but negative 1. So what's left on the top? 2 times negative 1 is negative 2. What's left on the bottom? Just 5 plus x. Okay. Let's try another one like that. In problem E, we have x squared minus 6x plus 9. And on the bottom, we have 18 minus 6x. Now, I think we've already factored x squared minus 6x plus 9. And that was x plus 3 times x plus 3. Now, on the bottom, we want to take out our common factor, which would be 6. So 18 divided by 6 would be 3. Negative 6x divided by 6 would be negative x. All right, so what I want you to notice here is we have x plus 3 and 3 minus x, which equals negative 1. So our final answer would be negative 1, which I don't need to write the 1, but I will. I'll write it first. It would be negative 1 parenthesis x plus 3 is what's left on the top. And on the bottom, we have a 6. Now, alternatively, this is more than likely how you're going to see it if you have a multiple choice problem. They won't put the negative 1. Just know they're the same thing. All right, pause the video and try problem F on your own. All right, welcome back. Let's see how you did. All right, when I factored the numerator, I used 2x times x for 2x squared. And then I used 5 and 1 for the 5. And I made the 5 negative and the 1 positive. For the bottom, I factored it to 5 plus 2x and 5 minus 2x. So then I highlighted the factors that equaled negative 1, 2x minus 5, and 5 minus 2x. So I know those equal to negative 1. So I'm going to put a negative 1 up there. And so what I have left for my final answer is negative parenthesis x plus 1, and on the bottom 5 plus 2x. And that concludes today's lesson on simplifying rational expressions.